More and more children are out of school, but parents don't want math learning to stop. They're turning to Mathnasium at Home. Real-time math instruction tailored to your child's exact educational needs. It's the same face-to-face live instruction used in our centers for over 15 years, now on a computer. Your child can keep their math skills sharp, catch up, or soar ahead, from home or anywhere with an internet connection. To learn if Mathnasium at Home is right for your child, visit mathnasium.com/at-home. Mathnasium at Home, changing lives through math.
Hello everyone. Welcome back to Mathnasium Schoolhouse. Love to see you guys beating me to it, saying hello to all of us here. Happy to see the same students here with us today. And all of the new faces or names with us. So please share who you are, where you're from. If you go to a Mathnasium, I'd love to see that too. Go ahead and share this video as well to help out your friends and family members who are interested or maybe need some assistance on, of course, problem solving with percents. So today we're actually looking at part 2 of a series. So if you joined us yesterday, we started this conversation on problem solving with percents. That also builds on a previous series we had on problem solving with fractions. And today's just part 2. So we will start off by continuing where we left off yesterday and then look at some new problems as well. For those of you that are new, there is a document that you can follow along with that's been shared in the comments or on our Facebook page. So you can go ahead, find that and follow along if that's more helpful for you. Yeah, I'm happy to see us going as well. I love that we get to continue these videos, these lessons with you all. And find, more and more topics that we can help you all with. And don't forget that here with our Mathnasium Schoolhouse lessons, we're going through a series of problems. Hopefully what brings you here is an interest and an opportunity to practice a lot of what you might have already been introduced to. If you need further assistance, if you need more challenging work, or you need to practice more on the prerequisite skills that build to these problem-solving questions, go ahead and reach out to your nearest Mathnasium. Our Mathnasium at Home program is a perfect solution to that, creating a customized learning plan where we get to really see what it is that we should be working on for you. Okay? So let's go ahead and carry on with our conversations. Our discussion today on problem solving with percent. I love to see you guys continuing to say hello. Please keep that up. I love the community we build here together. Where's the worksheet? It should be attached in the comments below. I know one of my helpers will point you to it in just a second. So I'm going to go to my whiteboard here. And let's briefly review what yesterday was about. So if you were here, you can help me out in the comments, but we looked at finding different parts to problems dealing with percents. Okay, so namely word problems, and that's what we were looking at, and I'll share that in just a second. But we had scenarios where we essentially built equations dealing with the percent, right? Multiplied by the whole. Summarize what we did yesterday and finding the part. Okay, and so the types of problems we worked with yesterday, we either searched for or solved for, I should say, the percent, or other problems we solved for the whole, or still other problems we looked for the part. And it all depended on what information we were given in the word problem itself. And so you can think of the equation reading to you, okay, the percent of the whole is the part. Let me make that more obvious that that is of, okay? So what the steps that we took to solve the word problems, which we'll continue with today, was to identify what we're looking for. Is it the percent? Is it the whole? Is it the part? Okay, once we have that, we filled in an equation. We used variables for those unknowns. And then we either used our logic when it comes to understanding the definition of percent to solve those equations, or some of us turned to some of our algebraic ways of solving linear equations, which was to isolate for the variable by dividing or multiplying both sides whatever works best for you. Yeah, not a problem. So in case you guys weren't there yesterday, that's what we did. You can always go back to that. And if you were, hopefully that is exactly what you remember from yesterday. Okay, so let's look at some of those problems. So I have some of the problems we didn't get to finish yesterday, so I'll finish them here before we turn to two newer types of percent problems you might encounter with problem solving. So let's look at a few more problems using those types. So you are going to help me out by telling me, is it the percent we're looking for? Is it the whole, or is it the part? So what if I told you that we have a basketball costs $80. Just looking at the worksheet from yesterday. So a basketball costs $80 and it's given, let me just even write, a $16 discount. All right. So what is the percent of the discount? So first, let's identify what it is that we're looking for. And in other words, that means what is our unknown here? Basketball or whatever it is that you want to call this item or pretend we're looking at here. Something costs $80. It's given a $16 discount. How do we find, or what is it that we're looking for here? The percents. Thank you so much, Nicole. That's exactly right. So our unknown here is the percent. And so you can choose your variable from there. We're looking for percent. Let's just call it a capital P. Why not? Okay. Yeah, the percent. And so how do we set up that equation to solve for that percent? Let me just find my other marker here. Okay, I see the number appearing. I see 20% discount. I love it. Do you want to explain how you got that? What do we think here? Okay. Well, if this is the discount, we have to find out how much is 16 of the 80. Right? So we're seeing some multiplication occurring there. I'm not sure where that's stemming from, but 20% is exactly correct. Yes. Right? And so if you think back to the equation that we had just a second ago on the screen here, what percent of the whole gives us this discount? So we're solving for an equation that looks like this. P times 80 is equal to 16. And so if you take 20% of 80, you get exactly that. All right? All right. Yeah, oh, I see a beautiful explanation from Cindy. Thank you so much for sharing. So you said, well, let's say I'm solving this. One way I can look at it is dividing both sides by 80. And so you're left with something like 16 divided by 80. Okay, and you said we can reduce that, which is exactly a technique that we used yesterday. You can reduce that. You said we can go to 4 over 20 first, and then we eventually end up at 1/5. And then, let me just follow your logic here. You said that 1/5, well, you can divide 100 into 5, where each of those have 20, which is 20%. Perfect, that's exactly right. Very nice, thank you for sharing that. All right, maybe let's do 2 more from yesterday before we carry on to new problems. So let's say that in a survey we had 40% of people liked, I don't know. In the problem we had brand X. Pretend that's, I don't know, something that you enjoy. Some sort of drink, let's say. 120 people liked brand X. Okay. If you're following along with the word problem, I'm kind of just summarizing here the information that I'm given. And then the question is asked of me, well, how many people were surveyed? First question you want to ask yourself is, what am I looking for here? Meaning, what is my unknown? What am I being asked to solve? Well, if the question itself asks how many people were surveyed, am I looking for the percent? Am I looking for the whole? Or am I looking for the part? I see the answer appearing. Very nice. Brand X, you can pretend whatever you want it to be. Okay, so I see 300 appearing. That is correct. How do we get that? So let's fill out an equation based on what we saw earlier on the screen here. It looks like I have my percent, so I'm not looking for that. Does it look like I have my whole or my part? It looks like I have my part because I was told that 40% is represented also by 120. Okay? So I can fill out that equation from before. Let me just write out my unknown here. I am looking for, what did we say? The unknown is the total, we can say, let's just call it the whole. Let's keep that same language. And let's just say that we're going to call that variable W. Okay. And so if we're looking for that, let's use our equation from yesterday. So we have our percent, so 40%, we kind of wrote it as a word equation yesterday first, so 40% of some number. Yesterday we kept on saying of what number, so maybe I'll just even say of W is 120, and if I translate that into an equation, we convert our percent into a decimal, and we say 0, or we can actually say 4/10 multiplied by W, and for those of you that need that multiplication symbol there you go, is equal to 120. And for any of you that want to share how you got your answer, I'm just scrolling to see how many of you did. Yeah, 40% is 120. Thank you for sharing that. I see 120 divided by 40 appearing, which is 30. Okay, so nice reasoning there. Very nice. Okay. I see a lot of you guys showing me 300. Okay, perfect. Yeah, and that's exactly right. So you'll get 300 from here. All right. Let me write that over here. Okay, perfect. And again, you can carry that out with dividing both sides by 0.4, or you can think back to our definition of the percent, which we used a lot yesterday, and think, well, if percent means for every 100, for each 100, how many hundreds do I need to get to build, how many hundreds do I need where I take 40 from each to give me 120? Well, 120 divided by 3 gives me 40, and so I would need 300s here. All right, let's do one more, and then we will jump to new types of problems. I will erase this. The percent is usually a smaller number. Okay, in some cases, in this case, we'll encounter some, in today's problems, we'll encounter some scenarios where the percent is actually larger. Right? Or maybe you mean the part is smaller, okay? Which, yes, would definitely be true as compared to the whole, okay? All right, perfect. Let me select one that uses a smaller part. So let me look at, I'll give you a third type of problem here. So we have 51%. Let's make that neater. 51% of students are boys. Let me just write it that way. 51% in a school, let's say, are boys. There are 200 students altogether. My question to you is, how many are girls? All right? So how many are girls? So far I don't know anything about the girls necessarily, right? Let's just say today in our school we're only going to group the students in two groups, girls and boys. And so I really can say, well, wait a second, I know how many girls there are. I at least know a little bit of information, because if 51% are boys, the only other group for us today is girls. So what's the other percent? what's that missing percent as compared to the whole, which is the 100%. So perfect. So as I finish saying that, I see it appearing. Christine wrote 49%, which is exactly what we're dealing with here, right? So I could say, you know what? 49% are girls, right? Or we can write out an equation and solve for it in another way. First, we'd ask ourselves, are we looking for the percent? Are we looking for the whole? Are we looking for the part? Hopefully by the time I've said all of this for this problem, you've identified, well, first of all, I know we have the percent. I also know we have the whole because we just read the problem and it told us there are altogether 200 students, okay? Which means that we're looking for the part. So our unknown is the part. And we're looking not just for the percent, but the actual amount of girls, the number of students which are girls equals part. So we can call this, I used P before for the percent. Let me use A here for the part, just the second letter here. You guys can use whatever what works better for you. And then we set up an equation, okay? So we know that 49% are girls, so that's what I will use in my equation. If I want to write a word equation first, I could. I'm just going to go straight to my linear equation, convert my percent into a decimal, and I say 49% of the whole is equal to the part, which is what I'm looking for. And again, here I'm not dividing, I'm just multiplying, so I would do so here to find what A is. And if you do that, I've already seen the answer in the comments, you do in fact get 98. So 98 of the students are girls, and the remaining amount would be your boys. All right. Could you have approached this a different way? Absolutely. You could have stuck with the fact that you know 51% are boys, found how much 51% of 200 is, and just subtracted that from 200 to see what the remaining number is, okay? Whichever approach your mind jumps to first and just maybe is less work for you. Maybe for you it was easier to find 51% of 200 than it is 49%, right? Either way, as long as you justify your reasoning, Sandra is happy. All right, let's jump to other types of problems. So there's a few more you can turn to from yesterday's worksheet for extra practice. I'm going to turn to two more types of problems you might encounter with percents. And one deals with, I saw the comment earlier of percent is usually smaller. I think I just misinterpreted what that meant. But we're going to actually look at problems where percents are greater than 100%. So let me pose this problem for you and we'll turn to the worksheet in a second. So what if I told you that, I'll let you guys think about this for a few seconds before we find the answer. So including 6% tax, look at this real world problem. Including 6% tax, a basketball, let's just say a ball, so I don't have to write as much, costs, and I'll write this here, $53. All right. What is the cost of this basketball without the tax? So let me just say find the original, just to minimize how much I write on this whiteboard. Okay. I'm going to give you guys a few seconds. You don't even have to share the answer with me, but just think about how you might approach this, right? Or get an understanding for what this word problem is telling you. What information can you read from these words alone? What does the English tell you? And how can we write this in a math language to then solve for it? Okay. So if you're thinking here and trying to understand, well, hold on, what is this 53? What does the original mean? $53 already includes that additional amount you had to pay, which was the 6% tax, right? So think about when you go into a store, you're not just paying for whatever amount you see on the shelf for that item. You have to take into account that you're going to pay an additional amount on top of that, and it's usually given to you by a percent. And so whatever that percent of that item is, you add it on to the 53. So how we're going to look at this, maybe I'll use my red marker here. Given that we understand that, we've not only paid 100% of the basketball's cost, we're also paying 6%. So we're paying 100% of the cost plus 6% of the cost because that is the tax amount, okay? Which means we're altogether paying 106% of that original amount. And now that we know that, we can go back to creating our equation and then solving it from there. Then we're in our comfort zone, right? Then we're in our math world. We're set up with an equation and we know how to deal with that. All right, so we think of the word equation. I'm not going to write it down, but I'll say it out loud. We think of, okay, so now I'm looking for that original amount. So I'm looking for that part. So I'm going to say 106% of what number gives me this 53. And sorry, we're actually looking for, we're going to get a little bit iffy with our language here, but technically we're going to be looking for our whole here. We're just increasing that whole by an amount. Okay? So it's one of those scenarios that are a bit different from yesterday's because it looks like the part is actually bigger than the whole because we're increasing. Okay? Which is funny enough that that comment appeared today. Given all of that, let's write an equation. We know that we have to turn this into a decimal. Hopefully you've thought already what that looks like. It's actually going to look like this. So we already have a whole and 6/100ths here, multiplied by some letter. I would have wanted to call it O, but I don't want that to look like a 0, so let's just stick with N for number. And that's going to be equal to 53, and then we solve for that. And so here is where you can turn to solving a linear equation using your algebraic techniques. Divide both sides by 1/600ths. And when you do that, I think I got the answer somewhere. Yeah, I see Cindy says, and Jim says $50 is the original. That's exactly right. So let me write that here. The original, which in our case is N, is $50. And if you're unsure of your answer, whether it's for this problem or any other problems, go back and check. So go back, if I wanted to check that $50 was correct, I would go back and substitute into here. And so I would want to confirm that 1/600ths multiplied by 50, does it in fact give me 53? So I'd solve for this, and if I get 53, I'm happy. Okay, perfect. So that's one type of problem where you're given an amount that already includes an additional percentage amount on top of that. And what if we want to do almost the opposite, so under 100%? So let me erase this, and then we'll work on both types of problems. I'll turn to my PDF in just a second. Okay, so let me write another type of problem, and I'll let you guys consider it, and then we'll practice all of this. So what if this time you get, and I'll use just a name that I saw, Jim. I saw Jim commenting. Let's say Jim receives 60% of votes. We talked about voting yesterday, whether this is for school president or anything else. He received 60% of votes for something. His opponent, there's only one opponent, so there's only two people running here. His opponent got 160 votes. That's the information we have. And the question is, how many people voted? Okay, how many people voted? I'll give you guys, again, a few seconds to think about that. Okay. Just again, you don't have to necessarily come to the answer and share that with me, but I want you to just take in this information before I kind of show you the solution here and think, what would I do with this information if I wanted to find out how many people voted altogether? What would I do here? $240 people Nope. Try that one again. So there was 40% went to his opponent's votes, right? Yeah, great. That's a great way to look at it. Okay, so let's see what we can put together here. So who was it? Bola, and if it's a student on this account, correct me and let me know what your name is. But Bola shared with us that, well, given this information, I can already read something that is not even upfront told to me, right? So I've just read that Jim received 60% of votes, but now, knowing that he only has one other opponent, I can also tell myself that means that his opponent got 40% of the votes, because 60 plus 40 gives me 100. I love that you read in between the lines and you took that information, because now we can use that and say, well, we know the percent, we know two pieces of information now about this opponent, the percent, and then how many votes he got. Okay? Or he or she got, right? So we have two pieces of information, which is wonderful, because when we talked about these problems, we said there's typically three pieces of information we need. And so, of course, if we want to solve for one, it would be really helpful if we had the other two, which is why we're going to stick with the information we understand from his opponent versus Jim. Okay? So what's the word equation here that we can read? Well, going back to what we worked on yesterday, now that we've interpreted all of that, 40% of some total amount of voters gives me 160 votes. So let's write that down as a math equation here. Okay? When we have 40% of some number, we write that as we convert the percent into a decimal. We're going to multiply that with a number, and if I just have these side by side, for those of you that aren't aware, this just means multiplication. If you're not comfortable with that, I can always include that multiplication symbol there. I'll just fill it in. And then I just solve for n. Okay. Again, I can go ahead and divide both sides by 4/10, or I can use my definition of the percent. 40 for each 100. Okay, I have 160. Beautiful numbers to work with, because 16 divides, or 4 divides evenly into 16, so I can expand that thinking into the hundreds and find that this gives me 4 hundredths. All right, and there we go. So how many people voted in the election, whatever election it was? 400 people voted. Right? And it seems like a problem from yesterday, except we had to do a little bit of investigation in the beginning to find out how can we retrieve some more information from the information we were given. All right. Okay, so let me remove this. I'm going to share my PDF. We'll do a few more problems together. For those of you that are getting distracted, just focus on the lesson and it'll be well worth your time. All right, so let me share this with you here. So I showed you two more types of problems. So let's do some of these together. Okay, let's see how much we remember of it. So here we have, including 8% tax, a CD player cost $270. Let's find the cost of the CD player without the tax. So we worked on a problem very, very similar to this. I'll give you a few seconds to think about how to approach this problem while I pull up your comments here. And for anyone that maybe joined us later in the lesson, I am just pulling up the document now, which is the follow along worksheet for our part 2 series. Now we're just practicing, not learning anything new. We're just going to practice what we learned today. All right. So including 8% tax, a CD player cost $270. So remember, this is between two of the types of problems we just looked at. So over 100% or under 100%. And here, I would start to think, okay, well, if I know that I'm dealing with tax, so it seems very similar to the first problem, but let's say I didn't remember that. How would I put 2 and 2 together? Well, I'd think I'm adding on an additional percent to my original cost of the CD player, right? So I had some original cost of the CD player, okay? So I had some original. And then I took 100% of this. So let's squeeze this in here. 100%. You know what? Let me make this bigger. So I took 100% of it and 8% of it. Okay. Then I multiplied by that original amount, and we don't have to write the whole word here. We can always just bring in a variable, which I will in just a second. And that cost $270. Now that I've taken those English words and I've written them into math words, I have my equation. I can make that even friendlier for myself to work with by saying, okay, I'm looking at a total of 108% multiplied by some number. I don't want to use O as my variable. That will trick my eyes to thinking that it's a 0. And that is equal to 270. And then I just solve for n. I'm not going to necessarily do this math here. We've done it over and over again. You can convert this to a decimal, perform that division. Hopefully what you guys are getting, yay, I'm seeing the answer appearing, is n is equal to 250. So the CD player originally cost $250. All right, beautiful. Oh, there we go. Rivali shared her equation with us. Beautiful. Okay, so let's look at problem number 2 here. Hopefully you guys can see that. Yes. Let's jump to that. So the number of people who saw a movie on Sunday was 25% more than saw the movie on Friday. Okay? 250 people saw the movie Sunday. How many people saw it on Friday? So give that one a try. I like to see you guys get excited over your correct answers. And yes, my friendly helper is reminding everyone, just make sure you're aware of your whole numbers, whether they're representing percents or not, okay? So just be very careful. So you can use the percent symbol in your word equations, and when you convert that into a linear equation that you're going to solve, you're converting it to into a decimal, all right? So the number of people who saw a movie on Sunday, I think I'm seeing some answers appearing here. Nope, not just yet. Okay, so let's see here. So the number of people who saw the movie on Sunday was 25% more than on Friday. So there was some Friday amount. Let me just start to write this down. Some Friday amount. And then you add to that 25% of Friday. This is at least the way that my brain kind of reads these English words and writes it into math words. And then that is equal to, I believe, yes, 250. Okay. And how can we confirm that? Let's read through the problem one more time. So the number of people who saw a movie on Sunday, this is the amount of people that saw the movie on Sunday, okay, is equal to 25% more than the people that saw it on Friday. Okay? So the Friday amount, which is the 100% of Friday, plus 25% of the Friday amount. So already you can start to see that you're getting to a percent that's over 100. Okay? And you could have written this differently on your page. This is just the way that my mind makes sense of these word problems. Again, I always joke that I take the English and I write it into math. And then from math, I'm good to go. That's my comfort zone. So if I take this information, I can write this as 125% of Friday. So let's just say of F, of some number F, is equal to 250. And then I solve for that. And this is one of those funny scenarios where typically our whole is bigger than our part. Naturally, logically, we want to say, well, duh, because a whole is composed of all of its parts. But don't forget, we're taking more than 100%, and so this number will naturally be smaller. And if you solve for F, we should get 200. So let me just write that here for any of you go. Let's do maybe one or two more and I'll let us go. So let's try number 3 here. 20% of the cars in a parking lot are red. 56 cars are not red. Already my brain is thinking, oh, we did a problem very similar to this where we were given information about 2 sides and then we had to kind of be investigators for a split second and then form an equation from there. So 20% of the cars in the parking lot are red, but 56 cars are not red. So what's the percent of the amount of cars that are not red? Let me ask you that first. And let's pretend, well, we don't even have to pretend, I'm sorry. It's either the cars are red or they're not red. So there's just 2 groups that we're working with, right? So if one of those groups has 20%, to make a whole, the other part has to be 80%, which means 80% of the cars are not red. We also know 56 of those cars are not red. So now we can form an equation. So if I take out my marker, I can say that 56 is actually equal to 80% of the total number of cars. And if I convert that into a decimal, that's what that looks like. And when you solve for that, you can correct me if I'm wrong, but I got 70 here. That's how many total cars there were. All right. There we go. So I see Simon is saying 14 cars are red. So there you go. You found how many are red. And so then just be careful what the question is asking you for, right? How many cars are there in the parking lot? So we're looking at that total amount. And let's do one more here, number 4, the last question on this first page. 25% of the people surveyed liked a new movie, and 45 people did not like the movie. How many people were surveyed? So we're going to take a similar approach here. We want to have 2 pieces of information to solve for an equation that could potentially have 3 unknowns, the percent, the whole, the part. Okay, great. We have that 45 people did not like the movie, and we also have the percent of people that don't like the movie. Why? Because we know 25% of the people like the movie. So how many people don't like the movie? Well, that would be 75%. Because 100 minus that 25 is 75. So forming an equation from there, I get 45 is equal to, what did we say? 75% of the amount of people that were surveyed. Again, let's just have an N there. You can have S, whichever one works better for you. And for those of you that aren't comfortable maybe seeing this on the right side, I mean, you could also, there's no difference in me writing it as, what did I say, 45? Okay. And again, I believe, you can double check my work, but I believe that should lead you to 60. Okay. There we go, and I see the answer there as well. Perfect. So I'm going to leave it there. I hope you've enjoyed part 1 and part 2 of our problem solving with percent series. There are a few more practice problems from yesterday and today that you can practice with, dealing with all the different types of problems you can encounter with percents. Of course, they could get a bit more challenging where you start to combine, let's say, a discount with a sales tax, okay? And you want to find either the original amount when you have the final amount, or you want to find the final amount when you have the original amount. So if you are looking for more problems that work with percents, reach out to your nearest Mathnasium. And again, we'll make sure that you have a learning plan that's built off of exactly what it is that your critical needs are. So we'll go from there, and we also have a bunch of extra problems that you can go through to get more practice, right? It's not always about just necessarily needing more assistance. It's just about wanting more practice. Because at the end of the day, math is super fun, and who doesn't want to spend their days working more on math? I'm going to leave it there. Again, share this stream if you enjoyed it. Share it with your family and friends. I really hope that you learned something new, or at the very least got to practice these skills again. We will see you tomorrow and next week for more Schoolhouse lessons. Have a wonderful day, and we'll see you soon. Bye-bye.
It's afternoons that seem to be the most hectic for us, so it was much more convenient when we found Mathnasium at home.
All right, so how do we do half of 5? I think one of the best things about at home is that it really feels like you're almost at home with the student in their house teaching them.
I'm in my comfort zone.
You can just ask for help and the instructor will come right to you.
With Mathnasium at home, I know that they're getting the help that they need.
Awesome, great job.
Mathnasium, changing lives through math.